Welcome everyone. In this video lecture, we will solve a question based on the MOSFET circuits at DC bias and it's from the Microelectronics circuit books. Example problem. So the question is, design the circuit shown below to obtain a current ID of 80 microampere. So we have to find the value of R and find the DC voltage VD. Let the NMOS transistor have VT 0.6 volt and mu n COX value 200 microampere per volt square, channel length 0.8 micrometer and W 4 micrometer. So we have to neglect the channel length modulation. So basically in this question, the given thing is ID 80 microampere. So we have to write very carefully and we have to find the value of R. Okay, and the VT value is given at 0.6 volt. Mu n COX value is given 200 microampere per voltage square and channel length 0.8 micrometer. Okay, so we have to write the all the thing which are given for micrometer or lambda given 0 means no channel length modulation, so we can write. So these are the basic things which are given. Okay, so now the first of all, this one is our NMOS. So this one is our gate in, this one is our drain in, and arrow always the source in. So this one is the circuit, very simple circuit looks like, and diode connected configuration. So here the gate and drain are sorted. Okay, so if gate and drain are sorted means VG is same as that of VD. Okay, so in which region it will operate first we have to know, because then after we will write the drain current equation. So here the simple characteristic curve we can say between the ID, the basic thing we have to know VDS. Okay, and it will go like this, like high pass filter response, and this value will be VGS minus VT. So this device, if VDS is greater than equals to VGS minus VT, then it is in the saturation region, that we have to know. It is very fundamental. And if VDS is less than VGS minus VT, it is in the linear region. This is a basic thing that we have to know. So here this one is in the saturation. Okay, and this one in the linear. This one is in the linear region. Okay, so now here we can easily observe that the VDS, that is our VDS greater than equals to VGS minus VT in this case, because this should be VD minus VS, VG minus VS. I am doing step by step. VS is common, so to ground it, so we can neglect. So VD will be always greater than VG minus VT. So when the drain and gate are sorted, it is always in the saturation, because this VD is same as that of VG. Here VD equals to VG. So always the this VD will be greater than VG minus VT, because VD is equals to VG. So gate and drain are this sorted. So this one is in the saturation region. So this kind of thing, gate and drain are sorted. So it is always in the saturation region. Saturation region. So that we have to keep in mind. Okay, it will be always in the saturation region. In addition to that, now we know the circuit is in the saturation region. So now we have to move forward. So what we have to write? We have to write the drain current equation in the saturation region. I am writing like this. So that formula you have to know. W by L is very simple. Okay, VGS minus VT whole square. So this current is in the saturation region. So what we can write? Simply VGS is not known to us, so we can find the VGS first. So ID value is 80 microampere. Okay, so write it. Then 1 by 2 mu1 COX is 200 microampere per volt square. So we can write the full with unit also. L and W is given. So W by L, so 4 by 0.8 into, I am writing here, VGS minus VT whole square. Okay, so we have to solve it very carefully. Microampere will be cancel out. So it should be 80 and make it 100. Okay, and if we remove these decimals, so it should be 40. So we can write as 100 into 40 by 8 VGS minus VT whole square. And here by volt square and volt square. Okay, so here volt square is there and volt square is. So I'm not writing the unit now. Volt square will be cancelled. So this one is the expression. Okay, so what we can do, uh, we can do like this one is 40, so make it 5. Okay, and this decimal will be cancel out, so one can write 8 by 50. Okay, VGS minus VT whole square. Okay, and we have to solve this one, very simple. So one can also write this as a 4 by 25, means if you divide 2, so 4, so it will be 4 and 25, so 4 by 25. Why I am writing like this? Okay, so this will be nothing but simply our 2 by 5 whole square. So one can easily write VGS minus VT equals to 2 by 5. So from here we can find VGS 5 by 2. 5 by 2 means if we multiply with simple 10 and 10. Okay, I'm just showing the how to solve. So this one is 2, so 2 to 4, 0.4. So 0.4 minus Vt, so it should be plus if we go like this. So 0.4 plus 0.6, so it should be 1 volt. So VGS value, our VGS value will come 1 volt. So this one is the VGS value 1 volt. Okay, now the VGS value is known to us. Okay, so I am writing here. Okay, VGS equals to 1 volt. Okay, so VGS is 1 volt, so one can write VG minus Vs equals to 1 volt, and Vs is grounded, so we have to write 0. So we can write VG minus 0 volt equals to 1 volt. So VG equals to 1 volt, and this VG and VD, G greater than everything same potential. So the VG equals to VD. Okay, so we have the value of VD, that is our 4 volt. Okay, so this should be our, sorry, 1 volt. 1 volt is known to us. So in our question it is also asking what should be the value required for the R and DC voltage VD. So VD is simply our 1 volt, we can say this one is our VD. Okay, now we have to find the value of R. So in such situation what we are doing, for just the simplification what I am writing, this VD is given known to us, that is our 3 volt, and this one is our VD is our 1 volt, and this one is your R, and current value we know I equals to 80 microampere. So one can write the value of I, or we can write the value of R. R equals to VDD minus VD by I, or ID, or in that one, so better to write I. Okay, or simply we can write this current, simply this current I flowing is this potential VDD minus VD by R, simple concept. Okay, so I am directly writing the R, VDD minus VD by I. So this VDD will be 3 minus 1 divided by this R value will be 80 microampere. Okay, and this one is in the volt, so 2 by 40. So we have to solve this one. Okay, so this one is 2 by, okay, sorry, better to write 3 minus 1, 2 by 80. Okay, 2 by 80, and micro, so we have to write micro is there, so it should be plus. Okay, I am writing plus this one, so it should be to 1 by 40. Okay, so 1 by 40. So what I am doing, writing, we are writing in terms of kilo ohm, so we are writing 1000 here. And this year cancel this 4, and this will be cancel out, so this one will be 25. So it should be 25 kilo ohm we can write. So R value will be 25 kilo ohm. So this is all about this simple question. So the R value will be 25 kilo ohm. So in that way we can solve a numerical, but we have to know the basic about the some means in which region the circuit is operating. So this is all about this simple question. So R value will be 25 kilo ohm, and this ID is already given. So 80 micro ampere is given. So like that you can solve this kind of problem. So this is all about this question. So I am writing here R value for this one is 25 kilo ohm. Okay, VD is our 1 volt, we have already find. So this is all about this question, design of the circuit. So thank you for watching this video. So I hope you get the points what I did. So thank you for watching and follow the steps step by step. Okay, thank you.